Thank you for the warm introduction. Hi, everybody. Let's start. My name is Andrei. I do work as an architect at Yandex Cloud, and my professional interests focus on authentication, API, security around all that, identity management, and all. I research this, I do publications, I have a Telegram channel on authentication and other things, API. We'll be speaking about API gateway, access tokens, and how to make them secure. We'll review approaches on managing access tokens in API gateway, what they are, how they can be, what the differences are. We'll speak about the required restrictions for the tokens and how to achieve implementation of these restrictions. We'll see how API gateway can be helpful in this regard. The systems are distributed now. There are many services, and it makes our security tasks more complex, including authentication and access control. This is not just login and password and issuing session IDs that you then call for or request. Requests can be different, by the way. Requirements to requests differ too, including InfoSec requirements. You need to navigate all this, and there are approaches for that. Different approaches differ. There are ups and downs, pros and cons, that translate into risks that you need to mind. To manage a risk, you need to first identify it. Let's also assume, for the purposes of today, that we use OAuth 2 for tokens. We will not dwell too much on OIDC and will not dwell on back-end for front-end client side too much. Why OAuth? Nobody needs that at all times. It's a framework to delegate access, including through access tokens. It's an important point for today. You'll need to see who gets issued a token and who then asks for it. Key definitions from OAuth allow us to dive deeper into approaches as they are without getting caught up in specific implementations. Distributed systems are inviting to different terms from OAuth, different resources and clients. And there are many of those. Let's speak about authentication of external system requests, north-south traffic. We know a procedure for an external authentication can be a user or a system. We have defined receipt of tokens or grandfall, with grandfall. Now we need to integrate with APIs to call or request terminal services. An important example here for today is API gateway. There are different pros and cons of using this pattern, but for the purposes of today, let's focus on these particular features. API gateway allows us to segregate perimeters. As you hear perimeters, you might protest and suggest zero trust. These are two different approaches, and you can borrow the best from them. You still remain aware of zero trust, but you have an entry point for internal services. When you need to prevent it from the outside, you need to define the outside, and it will be different in different cases. So this applies to internal networks as well. API gateway marries nicely with existing API management practices. We can automate checks and deliveries of APIs. This is publication of them to specific gateways. For different interface groups, we can ensure that there are required authentication procedures and authorization checks. In this regard, I should say that API Gateway is a nice point to do authentication, because that's where all the requests go to. That's why it's helpful to check tokens there. It's pretty much upstream, where you can screen out unauthenticated requests without forwarding them to actual services. In checking authorization, the preferred approach, where you have your policy enforcement point, tab, is as close to the end service as possible, so that it cannot be bypassed or sidestepped. This remains valid, but your policy enforcement point doesn't have to be just one. There could be many PEPs. First, rough authorization at the gateway level can be helpful to cut out some invalid requests that arrive to services and provide a safety net, an additional layer of consistent checks. Then you have external entity identity propagation. Identity propagation through API Gateway allows us to pass identities safely for external things. These entities can be used as systems. API Gateway serves as a component to validate external identities and pass information on it to actual services. It ensures integrity and authenticity of information. Using API Gateway enables consistent application of these practices in a diverse landscape at a given company. This is a slide with a book. It's a render, not even a paperback. Quite recently, I mean in March, very recently, they published Cloud-Native Authentication Security. They discuss API security architecture there, the authors. They mean secure access to API and the data that's fed through those. This concept relies on three pillars. There are three functions and key components for each. Identity access management is one of the functions, and the component is authorization server. Then you have API management, the component is API gateway, and then you have entitlement management. The component is the policy engine. I cite this because this idea resonates deeply with me. It shows clearly that security of API is a comprehensive task, which requires a comprehensive solution. You cannot get away with just one component that is isolated. It needs to be joint, orchestrated work of several components. It's a golden nugget of a thought, and I think it will apply nicely to what we'll be discussing. I haven't finished this book, but it's very interesting. It's not as cloud-native as it states in the title. It applies to other topics, including those that we'll be discussing today. So do look it up. So let's review the main approaches to managing access tokens through API Gateway. The first approach provides for an opaque access token, where you have introspection at each component. We have RFC specification and OpenID Connect specification that do not determine the format for access tokens. Basic standards give you an abstraction. It's a line where you have a delegated authority to the client. The opaque token is not to be parsed by other roles. For example, this would be a client or a resource server. It's an opaque line that's an identifier. That's why it's called pointer or reference as well. The data of the token is stored at the authorization server. There is RFC 7662 that defines introspection as a process where there is a component, a resource server, for example, or an API gateway, is used to validate the arriving token. Can be a refresh token as well, for example. There is an introspection endpoint that handles these requests. The response has metadata, activity, validity, and other things to check access. The client receives an opaque token from the authorization server. It goes to an API, to the gateway. It calls introspection endpoint. It receives a response, does the checks and validations, and then passes the request to the end server with the same token. It does introspection as well on its end. Data is the response from the introspection endpoint. This could be a JSON file. It's a good approach. Access token is aligned. There is no GWTs, no complexities that are attached to that. We have two-step checks, and we can assume that information is always current. But there are two calls to the authorization server within one request. It can drive latency and load on the authorization server. Another point to consider is protect against a direct request to the service bypassing the gateway. The format is the same, so technically this is feasible. There are optimizations to improve this approach. They aim to mitigate this many-step nature of the authorization. You can do caching at different points. You could consider making processing of introspection faster or cheaper. I've talked with people who implemented this approach, and they've been able to optimize it to a good degree, and the latency remained within tolerable ranges. The next approach. The token is again opaque, but introspection is only done by API gateway. Then you have context that's propagated as structured data, unsigned, a JSON file or some random format. The client receives an opaque token, it calls API gateway, introspection happens, validation happens, and then it's passed to the end server, to the actual server, with some data, not the token. The problem is obvious. The actual service needs to determine if it could trust the incoming requests. Integrity and authenticity are an issue here. There is no way to check for that. You can get a request with any data, and there are many actors who could be wanting to do this. We have one less introspection process. The token is the same, we don't have GWTs, but you get this extra task of securing trust, and it can be a problem. That information is important. It's used to do access control, after all. So things to consider include prevention of random data requests mimicking API gateway. Next approach. I'm sure many of you are aware, as knowledge and as first-hand experience, the token is always GWT, or, to be precise, it's one of the two manifestations of GWT. It's JSON web signature or encryption. We assume that GWT is the GWS representation. The client gets the token, it goes to gateway, and the same thing goes to the service. The diagram shows that there is no processing by gateway or the end service. The reason for this is that the access token is self-contained as a GWT. It has the information that's needed, and then local or offline check of the signature is carried out, so you don't have to make any requests. The component that relates to the token has a public key. Out of the pair, the private key arrives in the JWT, asymmetric. The public keys are propagated through the landscape as Jurukarai. It's a popular approach. It's promoted widely. Usually they say that you take GWT and it works like a marvel. It's good for microservices, of course, and then it promises horizontal scaling, as if everybody needed this. But anyway, they tout this approach as extra secure, whatever this means. If you know, do tell. Another important point here, adverts are adverts, but many of these promises will depend on the lifetime of the token. There are no miracles in this world, and the shorter lived is this token, the more requests there will have to be to the authorization server. So this approach is not as valid without adding a refresh token. The lifetime of the token will determine another important parameter, your approach to invalidating the token. Once you issue a GWT, you cannot revoke it easily. It is there by design. So you have to rely on its original lifetime. There is another approach where you have blacklisting. You blacklist the tokens that you want to revoke. There is an idea GWT or GWT. It's in the claim, and the component has to receive the identifier. There is this list that's maintained, assuming those tokens are invalid anymore. If it's blacklisted, the token is not accepted, considered revoked. This means that you presume the token's validity. This means that by default, a token is valid. So the burden of proof is to show the opposite by looking up the blacklist. If there is, for any reason, in this chain of delivery of tokens, there is a component that's malfunctioning for any reason, you might not get that identifier. So the validation component will not get the update that a token has been invalidated. That's what you get from presumption of validity. To improve reliability of detection of such failures, you can have the same chain with half checks, regardless of updates. That's how you verify that the entire chain is live and operational. You could also presume invalidity. Any token is not valid, and you have to prove or show that it is by calling the authorization server. For example, if there is no response, if it's not available, the presumption is that it's invalid. I think it's an important distinction. Back to the approach. It has some advantages. You reduce the latency, you reduce the load on the authorization server, you're less dependent on it, so it's better for scaling. You have the gateway and the services handling self-contained GWTs without any additional calls for validation. But there is a number of caveats or challenges still. You need to properly set the lifetime of the token. You need to have a mechanism for invalidation. The format is the same. If there is direct access to the server, especially from the outside, you can make a request bypassing the gateway. Then I've described the presumptions, validity or invalidity, can be important for some use cases, so do have this in mind. GWTs disclose some of the information to the clients or to end users even. But what's important there, we do not put confidential secrets there. Good point, valid point. However, you can disclose information on the internal design of your system, and it can be used by attackers with better visibility into your systems. Sometimes it's critical. And then we give this token to the client as GWT. If it's GWS, the client can look at the payload and reuse the claims. This means that GWT is, in a way, a contract between the authorization server and the client. An implicit contract, let's say. If you want to change the GWTs, you'll have to ensure that it's workable for all the clients, not just the resource servers. Here's another approach. I think it's the most interesting one. We have two tokens here. A reference token, the opaque one, and then we have the self-contained token. As an example, let's use GWT. The opaque token is just a line. The GWT is, well, it's what it is. We have a client who receives an access token from the authorization server. It's an opaque token. That's what it sends in a request to the gateway. But then the gateway calls an abstract security token server on the authorization service. I'll get back to it. It receives a GWT in response. The gateway validates it. If it's OK, it sends a request to the actual service, replacing the original opaque token with this self-contained GWT. The service gets the GWT, it doesn't have to call anything, and it can handle it on its own. Curiously, the end services only trust the GWT server. It's a good point that merits discussion. When we looked at one of the approaches where there is no signature, you could generate GWTs at the gateway. It could be convenient, but I wouldn't recommend. You'll complicate the trust issue. And here you have just one source of trust, the authorization server. We have opaque tokens on the one hand, and on the other, we have a GWT. And there is just one request to the authorization server. This prevents direct calls to the service, the actual service, even if it's exposed. The reason for this is that without going through the gateway, you cannot receive the GWT, and the actual service will not be able to process the opaque type of token. There are evident advantages in this approach. We have two types of tokens, external and internal, let's say, and our internal GWTs can be restricted. This segregates two representations of tokens. These are basically two different tokens. They can have different lifetimes, and we should, because we can set internal GWTs as very short-lived and restrict its application. It's a separate line. We can make it stateful, for example, to invalidate them. That's the external token. The client doesn't receive GWT, so they cannot misuse it. At the end services, we handle GWTs, and it comes with all the advantages from them. This approach can be more labor-intensive, more complex, so it's not always available out of the box. And then it impacts latency negatively because you have an additional call to the authorization server. And GWT signatures, depending on the algorithm, can be checked slowly. Let's discuss STS first, and then we'll speak about implementations. Security token service can validate incoming tokens and issue other tokens based on that. This allows you to handle accounts and credentials across different landscapes and heterogeneous environments. You need an access token. It doesn't have to be a separate service. It can be part of the service that does authorizations. And now on to implementations. Your mileage may vary in terms of details, but conceptually, you'd have either introspection or exchange of tokens. How do you do introspection of tokens? It doesn't require GWTs. But then again, let me explain. Bear with me. Just this year, this approach was codified as RFC, where you have GWT response to OAuth token introspection. Here is an example. You have introspection request. It has a separate header that tells the server, the authorization server, that it expects to receive a signed GWT. So then you see that the response contains an introspection endpoint response packaged as a GWT. There is an IAM solution where this is implemented to address, well, the topic at hand that we are discussing. It used to be implemented before when it was the draft, but not the point. Here is the catch. We have a request to authorization server. It sends something opaque. We receive a GWT, but what's in it? There are different GWTs. It's a response, an introspection response, packaged as a GWT and signed. It's not an access token per se. It doesn't have a lifetime, doesn't have its scope of application. It's a valid approach still, but not as broadly. You can look it up. It's called Purity. Purity, available online. But then we have token exchange, another means to achieve that. RFC 8693 or analogous but not standardized approaches. We have just one token based on the other, issued on the basis of the other. It can be restricted in all the necessary ways, as is provided for in GWT. Let me recap first. We've reviewed the main approaches in dealing with access tokens as applies to API gateway. There are different permutations of this, like split tokens. Just imagine they take a GWT, header, payload, signature. They take the signature and they make it into a reference token. The client has it. It calls API gateway with this, and the gateway stores the header and the payload. They then merge it. That gives you a proper GWT, just like in Power Rangers, which goes to the actual service. So there are variations, but I think we've reviewed the main abstractions. How to view these abstractions or approaches? I prefer where you have two different tokens, if security is key, if security is critical. Yes, you can have opaque tokens with introspection at each stage, or you can have GWT tokens, but you'll have to do some additional work. As for the approach, where you propagate the context as structural data but unsigned, I think that it's obsolete. I've shown you a demonstration, but I wouldn't recommend it for production-ready systems. These approaches are all useful. It's something to know, to be based, but is this enough?
Let us think about secure usage of access tokens as such. So sometimes it happens that we have a task of protecting access token against unauthorized use and reuse, replay attacks. Access token has certain temporal data, valid data, because if they leak, it's not important what kind of authentication factors we had and how the client was authentified. The intruder can act on behalf of the user within the framework's life cycle and area of usage. So I can tell you that leakage can happen not only outside when all the evil is concentrated, but inside as well, at the resource server itself. I can say that mitigating such a risk is important, and we can have three areas there. Protection against the leakage itself, protection against the reuse of token by illegitimate intruder, and limitation of the usage zone of the token through audience, through certain resources. I can tell you that complex measures should not be limited to one of these three areas. We can look at the third area in greater detail. What is the problem here? Look, if the same token can be used for access to any API, it brings about a risk of building a super token with unlimited area of usage. Then there is a question: how can we take an abstract token and create a limited token so that it cannot be used in unauthorized areas? So we talk about scope and audience. For scopes, what kind of access the authorized token can have. It's not the identity of resource. Scopes can be used for dividing resources, distributing resources, but it is not always convenient for operation. Let's look at the audience. For that, there was an approach which we had in RFC 8707, resource indicators for OAuth 2.0, which limits the area of access token by a list of resources. Let's look at the example. In the authorization request, we have a special parameter, resource, which can be used, and the same parameter can be added to token request. Why? For example, the user authorized access, and we want to have limited access, and we can say resource is here and limit the area of such token. Good approach, interesting approach, but it doesn't solve the problem to the end. The client gets only one access token, which should include all the necessary scopes and resources which are necessary for the application. That is good, but such a token, as we saw, can go not only through gateway, which is centralized, but it will go to the final services as well. And those services can provide it access to something else. We have certain limitation that is good, but this limitation is not always sufficient. And the teams might use such access token for access to something else with good intentions, maybe. You can start solving this problem by providing different tokens for access to different resources. This approach is possible if the client has BFA in AUF. For example, we have a server component where you have a refresh token with full area of activity. When we have a request, it will get a limited access token with only one scope for one resource. And then it will go to the service. Everything seems to be all right. The most privileged token will stay as it is without leaving its location, but we need a server location, which all services should go through. This is not always feasible. Such limitations are used when the request reaches the server area. Outside, there were some general purpose session ideas. Otherwise, we don't know how the application will work at all without that. We can think about it, but let us think about how to develop the original idea. The idea is good, valid. Maybe it has some points for optimization, and we go to dig it way. In the schemes, a gateway had some calls to authorization server, and simultaneously it can make changes. If we know where to send the request, let us limit the request powers, the request limits. I'll show you the example with two tokens. It can always be used with introspection schemes. With GBT, it's worse because it gets other calls and it's not as interesting in this case. We have a certain client which is not shown here. He gets an access token for a number of scopes and resources. It goes to API Gateway, and the API Gateway goes to the server to get access. It indicates a scope and the resource which are needed to process this request. It's necessary to note that in this case, it's very good for API Gateway to confirm its authentication so that the authorization service we can control access. So no random party can go and exchange tokens. If everything is okay, then authorization server sends the GVT access token. It was down scoped, it had limited scope, limited resources because of the audience. API Gateway validates GVT and sends it to the end service because it replaces it for the initial non-transparent token. It goes to the final service, and the final service checks the authentication, and the token is down-scoped, and it can act only within the area which is necessary for this operation. It's important to point authorization server should be sure that he downscopes and not upscopes the area. For example, we have the all scope zone, all resource zone. It's shown. There are some smaller zones, non-transparent token, blue, and the smallest one for the final token. We have downscoping 1 and 2. However, there is a logical question. How API Gateway could know what kind of resources and scopes are necessary for this particular request? Let's recall that we mentioned API publications. Who knows that? Final services. They are API owners. When you publish APIs, API management, route to APIs, they can also indicate necessary resources and scopes for different services and work with them. Also, the access token and the request from the access token, which tries to get access to unauthorized resources, will not get such resources. Look, the idea of using scopes in this way is not new. However, scopes are not always used, and they are not always well used, and they are not always consistent. No matter how useful it is useful, but you cannot start using scopes and use it everywhere. It may be complex and it take a long time, but this approach can be simplified if you have management of resources, and you can apply scoping and it can improve the general situation. If you have audience for all services, you can downscope it by improving security. One API gateway is not sufficient. No matter what we write, if no one is going to use them, you will have no effect. We have to check not only API gateway, but at the level of each final service. We need recommendations and libraries. In this approach, we said that we have requests to authorization server, and we can think that for some loaded APIs, it can be important. Well, what about caching API gateway? The life cycle of the token can be small, and the scope is limited. And I see a problem here that now we have a place where a lot of access tokens are stored. If such storage is compromised, then you can have a large-scale leak of the tokens. So this is a risk. You have to mitigate that risk by a short life cycle, by limited scope, but still this problem does exist. Now let us finalize what we talked about. We discussed the usage of API gateways, which might be useful to solve the problem of secure access to tokens. We looked at different approaches to access tokens, how different they are from each other. We spoke why do we need to limit the scope of access tokens. We talked about super tokens and why they are bad, and what we can use with the help of scopes and audience with a list of resources. And we also say how we can use API gateway for additional limitation of access tokens. And to conclude, I want to say that the approaches that I mentioned can be complex and they can reduce the speed, they can reduce performance. But I believe we need to optimize this process rather than focus on insecure by design solutions. So this is the end of my presentation. You can write to me in Telegram. You can subscribe to my Telegram channel where I write about authentication and not only, and you can also evaluate my presentation and leave your feedback, which is quite useful. That's all for me for today. Thank you for attention. I am ready for your questions. Thank you, Andrei. Thank you. An excellent presentation. Now, colleagues, ask your questions into the microphone. I see hands rising, but please go to the microphone and ask your questions there. Hi, Andrei. Thank you for the presentation. It was technically difficult. It's difficult to analyze it at once, but I would like to focus on the problem of checking or verification of access rights. Can you specify so we can have scopes and claims into the token which define the access rights of the user? Yes, there are two approaches. We can put them into the token, or we can use an attributive model of access provisioning. We can provide access on additional elements like TP decision points and manage access dynamically through ABAC. Which of the options is better? What is better, to put access information into the token or use additional points with dynamic management? Expansion, downloading, downsizing, upsizing. Did you compare these two approaches, and what are the benefits and of each of them? Well, these approaches are not contradictory, and I didn't tell you about detailed verification. I was only talking about tokens, scopes of the tokens, resources of the token for initial authorization, and you can use that for initial rough authorization. We're not going to validate if a certain subject can perform such operation. No, we just check the token, whether it can be used for this purpose or not. Authorization in general, it's a big question, and you can complement it. So it's a rough filter. Yes, looks like that, as part of the more complex solutions. So they can complement each other, these two things. Hi, thanks for the presentation. You told us about authorization from API Gateway Resource Server, from scopes. What about authorization between client and API Gateway? How can we be sure that the client can get access? Is it the inter-service relations? Yes, GVT token scope. You authorize a specific token to the resource server, but each customer can make any request to any part of the API gateway, and your token can get access to any part of the gateway. Well, we are talking about service to service, or client going to any API, any client to any API. And what is the problem? Actually, when a client goes to API gateway, there is no authorization check, and you can send with the token anything between client and API gateway. You cannot record anything. How do you check that the customer addresses the area of API gateway that he is authorized? How do you check the authorization here? I am trying to understand you. The concept is not well understood. Well, let's put it this way. The client has access token. What is an access token? On his behalf, on behalf of the user, it gets some powers. It goes to a certain API through API gateway and gets to the final service. At the API gateway, what can we check? We can check the destination. Is the API, is the token authorized to go to the that API? I don't see any problem here. In any case, you check the scope when you go to API gateway. No, it's access to a resource. We can filter out invalid requests at an earlier stage, but we do not eliminate any other authorizations and authentication tools and methods. Thank you. If you have more questions, please come to me offline. Hi, Andrei. Thanks for the presentation. My question is like this. We talked about access to API gateway from outside. What about services? Services also address each other. Are they going via API gateway, or can they do it directly, and how to do it securely? Well, I thought about that. A question. I was expecting it. Service-to-service interaction is another subject. I didn't include it here. That is a separate, interesting task which requires its solution. Yes, service-to-service interaction. In some cases, we can go through API gateway, but this is an overkill, and you can go directly. What about access control? What about request authentication? You can have client credentials. You can use long life certificates. Pluses and minuses are there. The SPIFFE is another for short-term certificates. And so there are different approaches, but it's a big subject and out of scope of my presentation. It's an important question, but I didn't touch upon it. Yes, that is a problem, and it's very important, really. Hi. This year, we started installing the gateway, our own gateway, in-house developed, and we see the teams that reject it because they don't see the problem, which cannot be solved by Nginx. How to convince them to use the gateway? Two things. Do I have the time? Yes, you do. Now, first, what is API gateway? So there is a certain component which implements this factor. Nginx and API gateway, I don't see any link here. You can use Nginx as API gateway. API gateway is a function. You can install that functions everywhere. You can use even Lua. It's your choice. You had lightweight Nginx. I don't know your specific situation. I am just talking in general. You have to look at your specific in general. If you use an API gateway, you have to have certain reasons for that, certain functions that API gateway has, it can add to your infrastructure. It can solve the problems which different teams face, monitoring, multi-layer security. It can solve part of the problem and take the responsibility for such solutions. There is no universal solution. You have to understand why do we need API gateway, what for, and how do you implement it? Well, it's up to you. It's useful, it's convenient. Hi, Andrei, thanks for the presentation. My question is like this. We have API gateway, the service, we limit the scopes of the token for addressing this service. In this scheme, who guarantees that the configuration, the final configuration of the service and the API gateway would match each other so that in the server we couldn't have expanded scope, expanded rights to get tokens from other services? Well, the token is valid. You check it? Yes, it is. Okay. It's authentic. Okay, it will do everything. But who is responsible for the overall configuration of API gateway and the final access point, so that they would confirm the configuration? Well, if I got you right, let me tell you this. Well, yes, I had an example with API specifications. If the service publishes the API, then the service is responsible for that. The service is in charge. As for verification is concerned, who is responsible? Everyone is responsible in different scope. API can roughly check for authorization, but you shouldn't rely on it 100%. We shouldn't trust everyone. We should trust, but recheck if necessary. Even if API gateway passes this token through, then each service should recheck it. Everyone is responsible. Did I answer your question? Yes, you did. There are different teams. Consistency. Consistent. We have one team which is responsible for API gateway and another team who is responsible for the service. And through specifications, someone has to ensure consistency so that these two teams operate in conformity with each other. Especially when specifications are updated. If I got you right, I look at such tasks in the following way. It's API management in the company. If you have no API management at the enterprise, if it's a transparent gateway, it wouldn't work. If you work with API, if you have standardization and specifications, if you cannot use any handle, you have to publish it, you have to be authorized, then these tasks they belong to API management at the enterprise. It's a higher level. Sorry. Let us just continue discussion offline. Unfortunately, time is up. Andrei, thank you very much indeed. Let us thank the speaker. Evaluate the presentation. Don't forget to send your feedback. So, and as for me, Andrei, thank you.